So our next speaker has published over 65 NPM modules, and he told me yesterday that he's currently working on something out of the X-Men. And I tried to ask him a little bit more about it, but he was super secretive about it. So I hope that it's not just that his boss is a bald dude in a wheelchair. But we will soon find out. So give it up for Jakob Mattson.
Hey guys, thank you so much for having me. I'm only slightly disappointed so far, and I really thought these guys would perform the song themselves. So I'm Jakob, and apparently we've checked off Gothenburg death metal, bow tie, check, and they also said something about the X-Men, so let me explain that. I've been working in a ton of startups, started doing consulting, went on to ad tech, then I worked with customer satisfaction, and then I worked at a startup here in Stockholm called Fishbrain. That's doing really great. But just for the past month, I've actually joined a startup hedge fund. And a lot of people are asking me, what does that really mean? What is that? Because it's not like algorithmic trading or anything like that. It's more like this. So we have this one golden guy who comes into the office in the morning. He walks through this bulletproof door. I'm not kidding. Walking down this aisle and putting on this thing, and then out comes the money. Or that's the idea, at least. So we're building this Cerebro. Makes perfect sense, no? Anyway, well, what I'm here to talk about is love. Love for JavaScript, obviously. And also the fact that I love what these dudes and dudettes are doing for it. So I've been doing JavaScript for a long time, but one disclaimer first, and that's the fact that JavaScript is far, far from perfect. And it's not for everything, really. It's not for everyone. And if you think it is, honestly, maybe you should try to go to some other conferences as well. Not that they're going to be as great as this one, but still. But JavaScript is cool because it's like one of these really tiny kids in an anime, a Japanese anime, A person so short that it's not physically possible to be this short, but still packing like an awesome punch that is literally to die for. So what I want to do today is to talk about some of these moves that this kid is doing. And it's going to be a bit like a Swedish smorgasbord, where you can find a lot of amazing things in there, and it's all quite simple. It's all not very complicated, but it still has great things. Like there are great ideas and great concepts and great flexibility within JavaScript. So it's going to be a bit of showcasing. Lots of code, short snippets, not too much detail. I won't explain everything in the very, very details, but you can go back to the slides later. And I know some of you are going to know some of these concepts already, but none of you will probably have seen everything. So yeah, let's just dive into it. I think 3 of the things that I really like about JavaScript, or that's at least challenging to look at, is the first-class functions, obviously. That we can have a function that takes a function and returns a new function, and we can do that very smoothly and elegantly compared to many other languages. There's a ton of fun stuff to do there. And then there's the metaprogramming, which is not really a strength of JavaScript, but rather a weakness. But that poses kind of a challenge. It's fun to think about what can you actually do to have a program inspect itself and do some metaprogramming. So we're going to toy around with that a little bit. And then finally, it's one of the most obvious ones, I think, which is the fact that JavaScript don't have classes, but everyone keep doing it the wrong way anyway, even though they already know this. So I just want to give you my opinion on that as well. So yeah, cool. So let's start with the functions. And we can start with one of my favorite examples, which is in error handling. And a pattern that we see a lot in JavaScript is that We have some asynchronous function doing something, like getting something from the web. And then we have a callback that takes care of the result, and it receives an error or a successful result, depending on what happened. And we deal with the error, and then we deal with the success. In this case, I'm just returning the first name of some user here. It would probably be more complicated, obviously, but to keep it simple. And just like Bert said, there are other ways to do this. Like I'm a big fan of promises, and in a big program, I would obviously not do it like this. I would use promises, but sometimes you just write a simple script. Sometimes you're doing some small component that just has to be very compatible. Don't pull in a lot of libraries. You always end up doing something like this anyway, right? In some situations. But I really don't like the look of this. It's spamming our function with ugly error handling that's so obvious and so repetitive. So I usually do something like this instead. Now I've named the function p just so it's supposed to fit on the screen. But it's a function that takes two functions as arguments. It's an error handler and a success handler. So we're saying that if this function fails, just pass the failure back to the callback, CB here. And if it succeeds, then run this other function. And note that it's not taking an error anymore. It's just dealing with a success case. So it's a lot cleaner. We just have 5 characters added. Or actually, since we removed the error, there's barely any characters added. So this is much, much nicer. And I don't understand why all the libraries and things I'm looking in doesn't have this thing more often. It's so simple. Because you just define it like this. It's quite obvious if you think about what it's doing. It's a function that takes 2 functions. Error handler, success handler. It returns a new function, which is the actual callback that's dealing with the result. And we just check, did we get an error? Then call the error handler. If not, then slice out the remaining arguments after the error using the array slice method, the magic arguments object containing all the arguments that were actually passed to the function, and the call method to invoke the slice on the arguments, even though arguments is not an array. If these things are not already familiar to you, look it up because it's really powerful. And then using the apply function on the onSuccess function to pass in all these arguments, however many they are, spread out over the function. So it's like, I don't think I've ever written a program the past few years without putting this function in there, just to avoid doing this. And in CoffeeScript, it's even easier because CoffeeScript can handle these variadic arguments a lot better. Or conference script, as I sometimes say, because it fits on the screen. So yeah, it's super straightforward. And this is a really, really great example, I think, of how you can create a function that... I can jump back for a second there. So it's a really, really great example of how you create a function that takes 2 functions and makes a new function, and it becomes something really beautiful and useful, and it's not complicated at all, but very straightforward, nothing weird. And to paraphrase Douglas Crockford, when we need to solve a JavaScript problem, the solution is always to just add on another function. So let's take another example. This one is from the underscore library, which is the once method. That's turning a function into a new function with the difference that this new function can only be called once. Even if you call it multiple times, it will only run the original code once. And it's a little different compared to the first one, because this one is stateful. We're actually introducing a few variables here in the beginning, like a Boolean called, whether or not the function has been called, and then some result. And the new function we return, look at this fact, like has it been called before or not? And then if not, we invoke the function, once again using apply in order to bind the context correctly and passing on all the arguments. And then we set call to true, so we can avoid running it again if this function would be called once more, which would just skip the body of the if statement and return the result. And this is possible because of closures. which, I mean, you're JavaScript developers, you're probably not even thinking about it, because every time you create a function, there's a closure around the variables you're setting up. But it is kind of cool that even though the original function has already returned, the once function has completed, then this inner function will still remember the values of called and result. And it just happens without us really thinking about it. And obviously, it works like this. We can say that if we have some init function or something and call once on it, then we get the new function, and it will only be called once in practice, even though we call it repeatedly. So there's a little pattern in here, which I think is nice to think about, and it's the fact that what we just did was to add some state to a function. We have an original function, but we want to remember something about it next time we're calling it. We can extract that to create kind of a pattern. So let's say we create a function called stateful, which just takes another function as argument, and then sets up some state, just an object with whatever. And what we do then is that we, once again, slice out the arguments that have been passed into our inner function, the new one we're creating. And then we're passing in the state followed by the original arguments to this. So this is, now it's getting quite meta. Like, we have created a function that takes a function and turns it into a function, and it's supposed to be used to turn other functions into other functions. So I mean, we could use this to implement once, for example, to say that, okay, once is a stateful, a function creating stateful functions that has some state and an original function. And then the implementation is just the same as before, but without the var statements. We're just reusing the state from our state variable. And the reason it's kind of neater is because now we're expressing intent when we're using it. The other one, or I mean, imagine searching your code base for functions that are stateful or have added on state to other functions. I would be hopeless, because it's just var statements and functions. You have to read everything and think about it. But if you do it like this, you could just look for all the stateful expressions to see where am I doing this. So even though JavaScript doesn't have a lot of things, it basically just has functions. You know, there's no namespaces, no classes, no things like this. You can create your own concepts, your own templates, your own patterns, if you so will. And just as long as you name them properly and use them like this, it's quite easy to understand what you're doing. So that's for functions to functions, you know. And if you're not already familiar with all of these things, you should look into it, because it's so powerful. The call and apply method to invoke functions in more arbitrary ways. The arguments object slice to deal with the arguments. Bind, we didn't look into, but it's for pretty much assigning context and values of parameters without invoking the function. And then closures, of course. So, secondly, metaprogramming. And in order to not fry your brains too much at the same time, I'm just going to give you a pause, have you look at some kittens with lightsabers, and drink some water. Okay, unfried. So for this, we're gonna need an example function to work with, and I just created a really silly one that creates a full name out of a first name and a last name, and I think this probably only works in like 20% of the world, or even less. But yeah, it concatenates a first name and a last name into a full name by adding a space. So that's what we have. And let's say now that we want to turn this function into a function that doesn't receive multiple arguments, but instead takes an object with the arguments. As you know, many complicated functions, or functions that can be used in different ways and so on, look like this. And you might ask, like, why would I want to do this? But I actually had a real use case for this once, which was when I was doing like RPC, remote procedure calling from one place to another, like the client to the server, and you just want to run something server-side. And then maybe you have an interface that looks like this. Your site, and then / some function, and then pass in all the parameters you want to run. And if your functions are set up to receive an object with all the values, then you can just look up the function in some list of all the functions that you're exposing, and then pass in the query arguments, and that's it. As long as you're doing proper error handling and checking inside of these functions that the things that are being passed in are not malicious in some way, then this works perfectly. And it's just, you don't have to do any magic to add on more functions. So it's quite convenient. But the question now is, of course, how do we implement such a function that turns the first one into the second one? Anyone who has an idea, like straight off the bat? Up with a hand? No, amazing, cool. I'm saying something useful. So the first thing we have to do is figure out like what are the names of the arguments that we're passing in, because otherwise we can't expect the proper object. And we can actually figure out that in JavaScript, because a function, if you do toString on the function, you get the implementation of the function. And even if the actual body of the function is not defined in your code, or it's a native library or something, you always get the head saying function and then parentheses and all the arguments. So with just some regexping and splitting out all based on commas and spaces and so on, and filtering out everything that's empty, we actually can find the names of the arguments to a function. Looking weird, but actually quite simple. And then given that we know the argument names, we can implement this function args as object like this. We're getting in the function. We know nothing about it. It happens to be the full name function in this case, but it can have any number of arguments, any names of those arguments, etc. We just extract the names, and then we create a new function, expecting an args object containing all the arguments. And then for each of the original arguments of all the names, we map those over to what we got into the arguments object under the same name. So just a few lines, a little bit of magic, and then we apply those argument values on the original function. It's kind of funky, right? So now we can actually do this. And it's completely generic. It would work for any function. So let's really dive into mad scientist land, if you're not feeling like we're doing that already. Let's say, and I'm not saying that this is totally useful. It's more, demonstrate what's possible, what kind of mad stuff can you do. But let's say we want to rename the arguments of a function to anything at runtime. So for example, given the full name function, we could say that we want to rename the full name arguments to be snake-cased instead of camel-cased. And then if we pass it into args as object, it will turn it into something that expects snake-cased functions, for example. Or if someone else inspects it, they will find snake-cased arguments and so on. Does anyone have any ideas about this? No, and this one is a bit scary because it involves eval. And people are like, stay away from me. But there are things you can do with eval that's impossible to do without it. And usually performance of it is really bad and so on, so it's not something you should be doing at all. But there are situations where you can do really cool stuff with it. So this rename args function could be implemented like this. So the first argument we're getting is the or let's go back. Yeah, the first argument we're getting is the function that we want to rename the arguments of. And the second argument is the list of new argument names for it. So it would look like this. I've named the function, the variable that receives the function, something weird. You're going to see why in a second. And then we build up a string. It's a bit obscure just because I had to fit it on the screen. But we create a string with a function in which we join in all argument names with commas separated. So we actually create a function with these argument names. And then we set the body to just be running this original function with the context and arguments that are passed to the outer function. So we're not really using the new argument names more than just putting them in this string. And then we're running all the arguments anyway without knowing the names of them. And then we just eval that. And this will be a new function, and it will have the arguments that we assigned to it, and it will still run the original function. So there's no difference. It just looks different if someone tries to inspect it. And obviously, there are two things I've left out here. One is that we should really check before that the argument names are not something weird, so we get a Bobby Tables situation. And also, none of the argument names can be the same as the variable for the function. Because if one of them are called __ unique, then that will shadow the function on the return line. But we could add if statements for that and make the name even weirder for our function there to make it not clash. So that's like really mad sciencey stuff that you can actually do with JavaScript. And I have a little. If there's someone in here who's just sitting, a piece of cake, super simple, I have a challenge for you. So do the opposite. Take the full name to function, which receives the object with arguments, and turn it back to the original function, which accepts a list of arguments. I call it just spread arguments, as it spreads them out again. The first one to post a solution to that on Twitter with the hashtag gets free beer tonight. So yeah, there's some crazy metaprogramming for you. And it's basically all centered around inspecting functions. You could do even weirder stuff with that. And also eval, that I would probably not recommend for serious use, but it's kind of fun for making weird stuff and competitions and these things, you know. So, third, and this is the part that's, well, let's go back into more useful land. And that's about the classes, or the lack of class. And you all know how JavaScript works, or at least you think you know it. Originally, we have the new keyword, we have the constructors, which are functions, but kind of pose as types. And then we have these constructors.prototype, or type.prototype, if that's how you want to think about it. So the constructor is kind of your type, but on the other hand, JavaScript doesn't really have types. You know, if you do type off or something, it won't tell you, like, yeah, this is the type of your object. So, I mean, no wonder people are confused and don't really understand this in the beginning. And then they get used to it and fine, yeah, this is how it works. But it seems like everyone, everywhere, just wants to recreate the classical way, you know. If we look at CoffeeScript or TypeScript, or now even ECMAScript 6, they introduce these new keywords, like, oh, we can have a class, we can have an actual constructor that's just a constructor. We can extend other classes, we have super methods, and so on. And it's such a tragedy, you know? ECMAScript, that's the last one I expected to do something like that. Because everyone keeps forgetting about how simple stuff really is. And that's kind of the point of JavaScript. You know, they're trying to take this tiny Japanese kid and stretch him out to make a normal, non-anime person of him, and that's not the point. JavaScript is something different. That's why it has a place. So when it comes to inheritance, or doing something inheritance-like, object create is like the way to go. I mean, this is how you're supposed to do inheritance in JavaScript. We can create an object, like let's say animal here, which has a greet method. And then we can create a dog based on the animal using object create from an animal. We have a dog, and then we add on stuff to the dog. And then we can, from the dog, we can create a new object that's, let's say, an instance of a dog. In this case, Zelda, which is my dog. And then Zelda can greet someone, and it will say, "Woof says Zelda." I mean, that's a class hierarchy, if you will. But there are no classes. They're just objects. And we treat some of these objects, the animal and the dog, as blueprints. But they're only objects. The only thing that's going on here is that if we call a function on Zelda that does not exist on Zelda, it will look in the dog object instead. And if it doesn't exist in the dog object, it looks in the animal object, and that's it. What else do you need? Like, here it is. Like, no constructors. You can just run any code you want at any point. Like, why you don't need a constructor. You just run it afterwards. There's no types. There's just different uses of objects. There's no new, and there's no prototype. If you want the parent of Zelda to have a function, then you just add it to dog. It's quite obvious. Like, what's the problem? And then people start whining, you know, I want overloading, and I want all these features that classical inheritance has. You know what I say about that? What did Crockford tell us? You just need another function, and then you solve it. So, OK, let's say we want overloading. So we write a function that we call create and init that takes whatever we want to create the dog from, let's say animal, obviously. And then we add on all the functions that we want it to have. And now I've made it so that this function will pass in the super versions of these functions. So speak will get the super speak, which will be null because there's no speak method in animal. And the greet method will get the super greet method, which is up there. And now we can extend it using the super function and do something extra in the greeting there. Like, what's the problem? I mean, this function is, well, it's a little longer than the other ones. It's like 10 lines of actual code. It would be less in practice because I would write the lines slightly longer. But it's not hard. I mean, the point is that it's very simple, and JavaScript allows us to add on whatever we want to the language. It has a very, very simple core, and it's so powerful that we can do new stuff when we want to. So if we want inheritance to work this way, to have super functions, then OK, let's add super functions. Oh, that was hard. No, instead we wait for, what is it, like 20 years to get classes added into the language? Like, what the? So yeah, and also, I think, if you think about what is this object create function really, you will see something that's probably the most beautiful piece of JavaScript that has ever been created. Because this function did not exist until, I think it was ECMAScript 5. But anyone could create it like from the birth of JavaScript by just writing 3 lines. And there's some connection between that and that, right? The create function takes an object, and then it creates a constructor. It adds that object as the prototype to that constructor, and then it uses new to instantiate that constructor, which corresponds exactly to the 3 basic pieces you have to make up inheritance in regular JavaScript, the way people are doing it with prototypes and everything. So this is kind of like the JavaScript version of the laws of electromagnetism. You know, it's taking a few different ideas that are kind of more complicated on their own, combines them together into a unified theory that just is so simple. It just works, and you don't have to understand anything weird about types, constructor, what's this prototype object really, what's its relation back to the original objects. Suddenly you can just do this object create type inheritance that I showed you before. I mean, this is definitely not new. I think Crockford kind of pioneered the idea of doing this, and then it made its way into JavaScript. But what he wrote was this. I mean, it's quite funny because I had this in some other slide, quite old slide, and it used to say 8 years. Then I actually went to site yesterday, and it's like, okay, it's 14 years now. Let's update the number. So this has been around for a long, long while. But still, people don't listen. Like, no. I want everything that's in C++ and Java and C#. I want this language to behave exactly like these other languages do, which is a mistake. I mean, we should not try to turn JavaScript into what everything else out there is. We already did that once with a language, and that's C++. So this is why I feel like some of the true concepts of JavaScript, or the true ideas, are kind of becoming forgotten now, and everyone is trying to replace it with something else. So yeah, there's no classes, there's just object create, and you can do everything that you normally would do with a class with it, and its feeling is way more native JavaScript. So my timing is perfect. It's 11:59:27. So I hope I've blown some minds in here, at least in some areas, and that you will take a look at this and think about the pieces that you did not really grasp and actually learn something new from it. So I'm going to post this online, put it up on Twitter, or have the social media team get it out there. And yeah, thank you so much for listening. Come.